Hello, explorers! Welcome to Quantum, your go-to channel for unraveling the secrets behind how everything is made and how everything works. Today's journey takes us into the heart of construction as we explore the fascinating process of making cement. Are you excited? Although the terms cement and concrete are frequently used interchangeably, the two products are completely distinct from one another. The manufacture of concrete requires a number of key raw ingredients, including cement, water, and aggregate. Cement is one of the primary raw materials needed. The first step in the production of concrete is the production of cement, which is an essential binding element that's responsible for bringing together particles and water in concrete. Ordinary Portland cement is a type of cement that's utilized the most frequently. However, there are numerous other types of cement. It got its name from the fact that its color was similar to the stone that was discovered on the Isle of Portland, which is located in Dorset, England. Limestone and clay are the basic raw materials that are used in the production of cement. These materials are normally obtained from quarries through blasting or the use of heavy machinery. They're extracted from the crust of the earth. After the materials have been removed, they are transferred to the crushing facility, where they're broken down into smaller bits. In order to create a raw meal, the crushed limestone and clay are combined in the required quantities. This raw meal is then transferred to a mill, which is a big revolving cylinder. The raw materials are ground into a fine powder within the mill, which not only results in an increase in the efficiency of the subsequent chemical reactions, but also guarantees that the raw meal composition is consistent throughout. For the purpose of heating the powdered raw meat, a preheated tower is utilized in which the temperature is raised by hot gases emanating from the kiln. In the process of moving the raw meal through the preheater, some calcination takes place. This causes some of the carbonates that are present in the limestone to break down and create calcium oxide, which is known as lime. In a rotary kiln, which is a lengthy cylindrical furnace, the raw food that has been preheated and pre-calcined is introduced. A temperature of around 1,450 degrees Celsius, which is equivalent to 2,642 degrees Fahrenheit, is reached within the kiln. The raw materials are subjected to a series of intricate chemical reactions and sintering activities within the kiln, which ultimately results in the development of clinker, which are nodules that are about the size of marble. After being expelled from the kiln, the clinker, which is composed of calcium silicates, aluminates, and ferrites, is next transported through a clinker cooler. The cooler forces air across the clinker, which lowers the temperature. It's essential to cool the clinker in order to preserve its quality and prevent the creation of crystal formations that are not acceptable. After the clinker has been allowed to cool, it's next processed in cement mills with gypsum and other additives to make an extremely fine powder. To regulate the amount of time it takes for the cement to set, gypsum is added. Now that the cement is being prepared, it's time to locate the aggregate, which can make up as much as 75% of the volume of the concrete. The strength and consistency of concrete are directly correlated to the amount of aggregate, which is made up of sand and gravel. A well-graded aggregate, which is a blend of coarse and fine particles that's in balance with one another, minimizes the amount of cement that's required, which in turn makes the process more cost-effective. Now let's talk about the admixtures, which are the unsung heroes of the concrete manufacturing process. There are a variety of benefits associated with these chemicals, and they could be added to concrete in order to enhance its qualities. Plasticizers increase the workability of concrete and make it easier to mold and assemble without segregation. In addition to retarders and accelerators, there are many additional types of admixtures that can speed up or slow down the time it takes for concrete to set. The first thing that needs to be done is to determine the desired strength and qualities of the concrete, and then measure the quantities of cement, aggregate, admixtures, and water respectively. Concrete mix design is an altogether distinctive field of study that focuses on determining the appropriate quantities of raw materials to achieve the desired tensile strength through the use of concrete. Depending on the type of work being done, building codes dictate the proportion of cement, aggregate, and water that must be used. In order to achieve a consistent mixture, the next step is to properly combine all of the components. While the process of mixing concrete has traditionally been carried out manually on a level surface using shovels, concrete mixers are now routinely employed to automate and speed up the process. During the mixing process, cement particles are distributed uniformly throughout the aggregates to guarantee that the mixture is cohesive. After combining the dry ingredients, water is added in a slow and steady stream while the mixture is still being mixed. Through a process known as hydration, which results in the production of heat, the water and cement combine to produce a paste known as cement paste. The mixing procedure persists until the concrete reaches a consistency that's consistent throughout, at which point the workability is evaluated. It's possible to change the consistency by adding additional water or dry components, depending on what's required. After the concrete has been sufficiently mixed and has reached a desired consistency, it's next carried to its final site and poured there. It's possible to accomplish this by pouring it directly into molds made of formwork or by making use of specialist equipment such as pumps or conveyors. During the process of placement, it's imperative that segregation, which refers to the separation of coarse aggregates from the rest of the mixture, refrain from occurring. After the concrete has been placed, it must be adequately compacted in order to remove any voids or air pockets that may have been present. In most cases, this is accomplished by the utilization of vibrators or mechanical methods like rolling or tamping. By compacting the concrete, you can ensure that it's dense as well as having good strength and durability. Following the placement and compacting of the concrete, it's necessary to cure the concrete, which involves ensuring that the conditions of moisture and temperature are maintained in such a way that the cement may progressively hydrate and build strength. The concrete must be kept damp or covered with curing membranes, blankets, or plastic sheets in order for the curing process to be completed. The heating process might take anything from a few days to several weeks, depending on the quality of the concrete and desired level of strength. Following the completion of an adequate curing period, a variety of finishing procedures can be done in order to produce the surface texture and look that are desired. The adaptability of concrete can be increased through the application of various techniques such as troweling, smoothing, leveling, and the application of ornamental finishes. Cement is the material that's utilized in construction the most frequently. The United States of America alone is responsible for the production of more than $4 billion worth of hydraulic cement, which is then utilized in the construction of almost $20 billion worth of concrete. It's a monument to the widespread use and importance of this flexible building material that the concrete industry is estimated to be worth more than $600 billion on a global scale. Thanks for joining us on this episode of Quantum. If you crave more insights into the world of creation, hit subscribe and let us continue this exploration together. Until next time, keep questioning and keep discovering with Quantum.